Hello, my name is Berend Isermann. I'm working on project BO7, in which we evaluate mechanisms of diabetic nephropathy. Diabetic nephropathy is now the most frequent cause of chronic kidney disease in industrialized countries. It puts an enormous burden on the financial system and on the health of individuals. Therapeutic options to treat diabetic nephropathy are largely lacking, and in particular in the last 10 years we haven't really gained much progress. So I have been working on the diabetic nephropathy issue for the last 10 years plus in close cooperation with Professor Navrat and other members of the SFB 1118. We have been looking into the role of coagulation proteases and coagulation protease-dependent signaling for diabetic nephropathy. And we were first able to establish that the endothelium-dependent regulation of coagulation proteases indeed has an impact on diabetic nephropathy. We're able to show that the activation of a protease called activated protein C conveys cytoprotective effects, protecting glomerular cells from diabetic nephropathy. In animal models, we're even able to show that APC can reverse diabetic nephropathy. We're able to link this to increased ROS generation in mitochondria, and we were able lately to show that increased ROS generation in mitochondria causes sterile inflammation, which then contributes to diabetic nephropathy. This led to other discoveries which have shown that inhibiting sterile inflammation, or more precisely the inflammasome, actually protects from diabetic nephropathy, and again in animal models can even reverse diabetic nephropathy. So while we have established quite some interesting findings in the last years addressing the role of coagulation proteases in diabetic nephropathy and also strengthening the role of mitochondrial dysfunction and ROS, there have been some open questions which are remaining open and which we want to address next. Thus, it is not really well established what the consequences of diabetic nephropathy and mitochondrial dysfunction are beyond ROS generation. And this is one thing which we want to address in the future. We are wondering whether mitochondrial dysfunction has an impact of cellular metabolism, and by doing so, we regulate protein function via post-translational modifications and epigenetic gene regulation. We have preliminary data which would suggest that APC and other coagulation proteases via mitochondrial function would target these aspects and can actually reprogram the cells and allow tissue repair in the diabetic kidney. This would then allow, hopefully, to reverse the disease in the future. These are exciting findings which we have, but we need to follow up on this and to get the mechanism down and really find out how this works and whether it can be put into the clinic use. This is what we're working on at the moment.